طيب بسم الله الرحمن الرحيم. We continue with what we started last time. We went through last time about some definitions with regard to the categories of data, what is data model, and the types of data model that does exist. And we looked at the database schema. We said the schema, it is a description of the database itself, okay? And we said that the database should be stable, okay? It is expected to not to change frequently, because we need some stable database. And one of the schema diagram that we can use in our relational model is this type of schema or description. And we said that by looking at just this diagram, which specify the schema, it specifies the structures or the structure of your database. Okay, it shows that we do have a table or a construct or entity which is called student. We do have another one course, another one prerequisite, and so on. And the student, it is made of name, student number, class, major. Okay, and even this type of schema diagram, okay, it doesn't show everything. Okay, it doesn't show you the data type or the relationships between those different entities. Okay, and it doesn't show any constraint, but at least you do have an idea. We say this is a schema diagram. Okay, it is showing you the structure. You have a big picture. As we mentioned last time, we gave an example. We said you have a house, which is your database, and your house, that house has 3 windows, 5 doors, and whatever. Okay, we are looking at, let's say, from say perspective of the big picture of that database, and using the schema diagram, we can specify. We can have an idea about, let's say, at least an idea. Okay, at least you know 50%, 60% on how the database is structured. And each one of those, okay, this student or course or prerequisite section, it is called schema. Okay, it is called a schema. It is a construct. Schema construct. That means each object in this part, okay, we do have a student construct, we do have a course construct, we do have prerequisite construct. It's like a table. We say student table. In terminology of database, it is called a construct. Another information or another thing that we need to know about the database is, we say we do have a database state or database snapshot. What is meant by state or snapshot? It is the data in the database at that specific time. Okay, let's have a look. Okay, this is an example of a database state. What we can see here, okay, we are looking at, for instance, this construct or this table course. Right now, in the course name, I do have this data: Introduction to Computer Science, data structures, discrete mathematics, database. For the course number, I do have this information right now. Credit hour, the same thing. Department, I do have this data. So this is the data populated. We do have the data. That means when I am looking at the database now, right now, I will say that this is the database state, and حالة database. Now, okay, that means now actually the course table has this information. The section has this information. So it is what you are looking is a snapshot. We are not looking at the whole database, all the data that is contained in the database. Maybe we do have other tables that does exist or that exist within your database, but we are not looking at those tables. We are looking at just one part of the database. That's why we say we do have a snapshot. Like you are taking a picture or snapshot of the database, and this is our snapshot we took from our database. Okay, and actually this is the existing data. Okay, it is the current data that we are looking at our database. Okay, Shabab. Another thing which is related to the database, we say, sometimes we say that we do have defining a database or defining new database. What is meant by defining a new database? It means that you are specifying database schema to the DBMS. That means you are using DBMS as a software and you are creating a new database schema. That means, for instance, I will use DBMS and I will start by telling the DBMS, I have a table which I will call student. And that table has 1, 2, 3, 4 fields. The first field is named name. The second one is student number. The third one is class, and so on. So you are specifying, you are describing the structure of your new database or the schema. We say that we are defining a new database. By defining, that means you specify the schema, the structure. And once you define your database, once you create the student table with all those fields, what we need to do next, Shabab? When we create the database, we create those tables. We have defined those tables with different fields. What is next?
We need to fill them, doctor, or select the metadata.
We need to fill them with data. We call by populating. Okay? We need by populating, or we load that database with initial data, with the first data. Okay? This is known as an initial state. Initial state معناه the first time when you create your database, you will put the first information, the first data. And we say this is the initial state. That means we started our database with this specific data, the starting point. Okay? Because as we mentioned, the database might change over the time. The data might change over the time. But the first data that we put in our new created database, okay, we call that this is our initial state. We started by initial state by populating with initial data. The first data that we are going to store in our new database, we say this is our initial state. Let's start with initial state. Let's start with our database, okay, in the student table with 10 students. In the course, we start with 5 courses, and we put the data about those courses, about those students. And we say this is our initial state for our database. Valid state, what is meant by the valid state? That means satisfies the structure and constraints specified in the schema. Now, when we say, for instance, we include in the schema, we said we do have a name, student number, class, or major. And we specify that student number is integer. The data type of student number is integer. What means that? Means when you go to load your data and you go to put your data for that field, which is a student name, you are going to abide to that condition, which is the student number should be integer. That means if you follow the restrictions or a constraint or the data type of the name, student number, class, major, we say right now that we do have a valid state. Valid state معناه all the data that is stored in your database does not violate any constraint. If there are any restrictions, you have to follow, and all those data are abiding and following all the restrictions and rules that has been stated for all the database tables or construct. This is what we mean by we do have a valid state. The schema evolution. What is meant by schema evolution? معناه the schema or the structure of your database might change. Why the schema might change? Because sometimes we do have a new requirement. We do have a new requirement for university, which forced us to change some of the structure of the database. Maybe in the student record or the student construct, here we didn't include mobile phone, for instance. And the requirement now, new requirement says that we have to keep the mobile phone for each student. So what we need to add an extra field, which we call it here. We add it and we say, this is our new field, which is a mobile phone, and so on. Maybe we need to remove something. Maybe we need to change the relations between one table or one construct with another table. Okay, all those, that means through the time, you might have to do some changes to your schema or to your structure for your database. We say that the schema, it is a schema evolution. تطور structure of your database. Clear, Shabab?
Yes, Doctor.
Yes, Doctor.
Okay.
So, Doctor,
Now,
schema is how database development or
لا
evolve,
schema
right?
is the structure.
Structure, but you said
الشكل
تطور.
say it again. نعم.
You said, Doctor, تطور. Evaluation schema, you mean?
Evolution هو التطور.
Okay.
Yes.
Okay. Schema is the structure.
schema
and
is the
evolution
structure. معناها structure تبع database تتغير.
Okay.
through the time. مع الزمن تتغير. الستراكشر يتغير بسبب وجود new condition، شروط جديدة تقتضي أنك تغير من الستراكشر تبع database. Okay? This is what is known as a schema evolution. Okay, شباب?
Doctor,
نعم.
if there is no data, we call it's not a valid state.
لا. If there is no data, it is a valid state. Well, valid state, which means valid state.
I mean the initial state.
Yeah?
I got mixed up. I mean the initial state.
Initial state is the first data you put in your database. It's like you have your mobile phone. You bought a new mobile phone, okay? And you put the first contact number. You put your best friend. You will say that my contact. This is the initial state of the contact in my mobile phone. I started with saving my best friend's number in my mobile phone. We said this is the initial state, the starting point, the starting data.
Yeah, understood.
Okay. Now, in terms of, if you remember what we talked last time, we looked at some characteristics of the database approach. And if you remember, we said that the database, we do have, it is a self-describing installation of programs and data, or program operational dependence. You remember, we said that we do have support for multi-user views. Okay, here we specify an architecture for the database, okay, which provide us such, let's say, data and dependence. Okay, what we do have here, we do have what is known as a 3-schema architecture. Okay, in some database, okay, we do have a 3-schema database or schema architecture. Now, the idea about having this 3-schema architecture is to specify, or to separate the user application from the physical database. We do have user application is in one level, and the database, the physical, if you remember what we said about physical, we said that it is the way how you store your data. Okay, where do we store our data and how the data is stored in terms of physical matter. Okay, now in this architecture, the schema can be defined at 3 levels. We do have the first level, which is the internal level. When we talk about the internal level, that means that internal level has its own internal schema, which will describe the physical storage structure of the database. Okay, when we talk about the internal schema, for instance, for the internal level, we do have internal schema. And when we talk about the internal level or internal schema, we are talking about the structure of the storage of the data, how the data is physically stored in the database. We say that it is stored in files, and files are stored in USB, or in hard disk, or in the server, or in the cloud. And this is the way how the data is structured. Okay, and how the data, the access path, how we can access. We move from one place, physical place, to another physical place, how we can, which path we are using to move, and so on. So this is with relation for that internal level. We do have the internal schema associated with that internal level, which describes, let's say, the physical data. Like here, okay, we do have those three level. Okay, we do have here the internal schema, conceptual schema, and we do have the end user. Okay, here we do have the internal level. The internal level is related to the internal schema, which describes the storage of the data, the physical storage of the data. Okay, we have another level, which is the conceptual level. The conceptual level has its conceptual schema. Now, what we do have here in this level, we describe the structure of the whole database for some specific users. Okay, the structure of the database. Now, in this structure of database, we hide the details of the physical storage. We are not showing how the physical, as we mentioned, the physical storage, or the details, how the data is stored, it is at this level. It is not shown in this level. In this level, you are looking at the database only. You don't look at how the database is stored. Okay, you are just focusing on the data and concentrate on describing the data entities, the data type, the relationship between the data, what are the operations, what are the different constraints. These are stored, or these are described in this conceptual level, where we do have conceptual schema. Okay, Shabab? And we do have another level, which is known as external level. We call it a view level. What is meant by view level? Here we do have some external schema, user views. When you talk about user view, that means you are describing the database to particular user, some user. For instance, the user who are working in accounting office, they will look at some specific, they will be provided with some specific schema for the database. Maybe they are not allowed to see that in the database there is a student mobile phone or a student address. They will look only to the student ID and the fees, whether the status of the payment of the fees, university fees. You will find another user, for instance, maybe from let's say from the computer department. That employee in the computer department, he cannot see, for instance, the fee status for the user, whether he has paid or not, because he is not concerned about such information. What he needs to look at is that his student maybe has an ID and it is enrolled in this only CS courses. So if you can see here, we do have views. That means for each user, we call them end users, which are the users who are using the database. They will have access to that database from different perspective, and they will look at the data from a different perspective based on what, or let's say, what data they want to see within the database. Okay, so as we mentioned here, we said that the idea about having such schema, okay, we do have such level, is the idea is to separate the user application from the physical. Here, we do have some these users are using some application, and by using those applications, we are not aware and we don't need to see the internal level, how the data is physically stored in the data or in the physical storage, as we mentioned. Okay, you are using your software, okay, just to access the data, some specific data. You have access to some part of the database, and you will look at that conceptual schema from that perspective. Clear, Shabab, for this three level? If you remember what we said last time about the independence, okay, for the independence, we said we do have some independence between those layers. What is meant by data independence? It means that the capability or the capacity to change the schema, the structure. You can change the schema at one level of the database system without having to change the schema at the next higher level. Here we mentioned higher level. What is meant? It means that the data independence, if we are at the internal level, we can change the internal level or the internal schema. We change, for instance, the database. It was stored in server 1. Now I want to store it in an external hard disk. Okay. Now that changes done, or those changes done to the internal schema, it will not automatically force us to change the conceptual schema or to conceptual level schema. Okay, this is what is meant by the data independent. And the higher level, if we are at the internal level, if we do changes at this level, okay, it is not automatically, we have to change the next higher level, which is the conceptual schema. We don't have to change the conceptual schema. If we change the conceptual schema, we don't have to change the external level. This is what is known as data independence.
So each type of schema is independent to other.
Each level is independent from the other level.
But doctor,
Okay.
for example, when we change, for example, internal schema, if we know we change some property of it, sometimes we need to change also the conceptual schema.
Just let me give you an example. The same example we have been mentioning many times. You are accessing a browser. Okay, you are using Google search engine. صح ولا لا? You search for a keyword. You are searching for database tutorial, for instance. Okay. Now, how many times or what level of information do you know about Google company that they have been changing the structure or the physical storage of their database? Each time they change their physical storage, do you think that we have to change each time the browser based on that new changes done to the physical storage?
No, we don't need.
No, we are not even aware that they have changed the structure. They are freely to change their internal level as much as they can without affecting the user, the application of the user. Do you imagine, Shabab, that each time Google will change the physical storage from one place to another place, or they will change the structure of the file stored in their database, and they have to tell everyone or all the applications existing in the world that you have to change. We have changed the physical level. You have to change your application based on our new schema. It's not like that. The same thing when you are accessing here in PSU, for instance, your account. The IT might change the internal schema of the database. They will move the data from one server to another one, from one file to another file, from one directory to another directory. But you are not aware. You are always facing, you open your computer within PSU, you are faced with username, password, you enter your username, password, and you get your account. You don't have to change everything. And this is what we mean by the data independence, the capability of changing, of doing changes in what level without having to change the next higher level. If you do changes at the internal level, you don't have to change the conceptual level or the conceptual schema. If you do changes at the conceptual level to the conceptual schema, you don't have to do changes to the external level, and so on. Clear, Shabab?
Yes.
Yes.
Okay. Now, as we mentioned now, we said that we do have that data independence, okay, which is known as physical independence, logical and dependence. We do have logical, which is considered changing the conceptual schema without changing external, which is here. We choose the conceptual schema without changing the external, or we change the internal level. When we talk about physical, we change the physical internal level without having to change the conceptual level. Now, once you do your design, okay, let's say now you have done your design. I have designed in a piece of paper that my database should contain student table, course table, prerequisite, okay? And you have chosen your DBMS. For instance, I chose my SQL software or a package, okay, to implement the database, to create it inside the computer, because all these are designed. We didn't move to the next level where we create, we implement, okay, this draft that was in a piece of paper or in another tool or another software. I want to implement it inside the computer. I want to create really database that does have student course prerequisite table, for instance, okay, which the first step is to specify the conceptual and internal schema for your database and do some mapping between conceptual, for instance, and the internal level. Okay, we are here, for instance, when you do to create your database, I want to do some conceptual schema and I want to specify the internal schema. I want to create this database. Okay, I want to define my database and to define the structure. Where do I have to store my database? Okay, and sometimes you do find, sometimes we need to do such mapping between conceptual schema and internal schema. And in some databases, okay, you will find that the conceptual level is included with the internal level. Now, what we are saying here, this schema or this three schema architecture, is just for the sake of for your understanding, to understand how, let's say, it is beneficial to use the database approach, okay, and how, let's say, it is easy to use database and how easy it is easy to change one level without affecting the other level, and so on. Now, in terms of database, sometimes we talk about here what the DBMS languages. What are the DBMS languages that can be used to create your database? Okay, whether to use the conceptual schema or to the internal schema. There are many languages, okay, where at the end, this is just for you as an information, but at the end, you will see that all those languages have been packed in one language or database language, which is SQL. Okay, that means within SQL, okay, there are some commands that are considered as data definition language. Some commands are used called storage definition language, and others are used the view definition language. But now, what is a data definition language? Okay, it is used by the database administrator or any database designer to define both schema. If you want someone who is defining conceptual schema and the internal schema, he will use a language that is called DDL, data definition language. Okay, if, for instance, now once you do that creation, you create your database and you want to specify in some other database. Here we talk about if we do have a separation between conceptual schema and internal schema. As we mentioned, in some database, in some DBMS, this conceptual level is separated from the internal level, and in other DBMS, conceptual level and internal level are within the same level. They are packed together. Okay, now if we do have that separation, we are going to use database definition or data definition language, or the DDL. And as we mentioned, in some, let's say, some DBMS, we need to specify the internal schema. What we use the SDL, which is the storage definition language. If you see here, we are talking about storage. That means we are using physical things. Here, we use the SDL language to specify the internal schema, which is the physical storage of the data. If you want to specify how the data will be stored, what are the indexes, the access path, the structure of the files, how they are organized inside the database, you will use this type of language.
Doctor?
Now,
so what will be the difference between define internal schema or specify internal schema?
it is the same thing.
So any data definition language use define internal schema and storage specify internal schema. Both of them same work?
Here we talk about DDL. We said DDL. If it is separated, if you do have conceptual schema is separated from the internal, okay, you can use DDL.
If they separate.
Okay, yes. Now, if they are in some languages, they are together, they are packed together. So what you need to know, you need to use another language, which is the SDL. Okay, specifying or defining is the same thing. Okay, for this SDL is only for the storage. However, for the DDL in some DBMS, this DDL is used for conceptual and internal as well. However, for the SDL, it is only used for specifying the internal schema, not the conceptual one. Okay?
When they are separated, we use the SDL, doctor?
Say it again.
When they are separated, each one is not related to the other. We use SDL for internal.
Yes.
Okay.
We do have another language, which is known as view language or view definition language, which is VDL. VDL, we're going to see later, and when we cover, inshallah, the SQL chapter, that we can create what is known as views. Views, that means you will, briefly, you will run some SQL command or query, and the result of those query will be stored in your database. Okay, and in DBMS, in the relational DBMS, the SQL language is playing the role of that VDL, which is the view definition language, because it is used to create those what is known as views. Okay, we're going to, inshallah, cover it in a separated chapter. Okay, Shabab? We do have a data manipulation language. What is meant by data manipulation language? That means you will use some commands that will help you to retrieve some information, to do insertion, to do deletion or modification. Any type of manipulation of the data, you will use a specific language. Here, when we say specific language, that means you are going to use some specific command. Okay, and the same thing in the relational DBMS. All those, as I mentioned previously, this DML is included in SQL. Okay, SQL contains all those languages, whether you want to create database, schema, internal, DDL, and so on. Okay. Now, in terms of interfaces, when you talk about interfaces, how do you access your, let's say, or what type of interface or interfaces are provided by different DBMS? Okay, we can find a menu-based interface for web client or web browser. Sometimes some DBMS will provide the user or the end user a menu, okay, a list of options, which is the menu, and the user will go through that, let's say, through that menu, will choose some options, and that option is sent as a request to the database. Okay, so this is what is known as menu-based, or you can have a web-based user interface. Okay, usually this is what you find in the internet. For instance, when you access some website and you want to buy some items, you will be provided by a menu with a, let's say, a drop-down list. Okay, and you go through that list and you choose whatever you want. You click on that one, click search, and it will try to find that chosen, for instance, item within the database. Here we talk about the interface. How can you access the database? What is the interface? What do you see if you want to access the database? Some of the DBMS will provide you with this menu base, or for the web client or browsing, for instance. Yeah?
So any web page that contains information from a database is considered a DBMS interface?
Yes, it is a menu. If you have a menu, drop-down list menu, okay, this is an interface for you. This is an interface. Okay, for instance, you access a library website and you want to search through books. You will be given a list or a menu which has a list with a drop-down arrow, and you do just, for instance, you want to filter or refine your search. You search for books, for computer books, or grammar books, or math books. You will be presented with a menu, and you just click computer book or computer's book. Then you will be provided maybe with another menu, and usually you find that in the browsers. Most of, let's say, of the interfaces, or most of the database that are using web interface, usually they do have such menu-based interface for their users to access the database.
What about dynamic web pages? Because some web pages, they contain text and images. That's actually, all of it comes from a database. So it's fully dynamic. Is it also considered a DBMS interface?
Here we are talking about you are going to access the database. How? What is the way to get the data from the database? Okay, we're not talking about how the web page is done or how the web page is designed, whether it is dynamic or no. We're talking about if I want to access libraries database, how do I access it? Okay, now one of the options that might be done by maybe the people who are responsible for defining the database for that library, they will use a web browser. They will create an interface that you will access the database through a browser. And usually when you access database through a browser, you will face a menu-based interface. You will have some menus, and you choose through the menu. You go through the menu and you choose whatever you get, and whatever item it is displayed there, you just click on it. You don't have to, for instance, type your keyword search. You will be presented with a list which is based on the menu. Okay, here we are specifying, we are talking about the interface itself for the DBMS. Okay, as you can find, for instance, a form-based interface. Sometimes you want to search for something, and you are not faced with the menu. There is no menu. There is a form where you fill the information you want to look for, and you click search, or click OK, or send, and it will take your input and translate it and search based within that database based on your input. Here we talk about the form based. That means when you want to search and you want to access your data or the data inside the database, that DBMS is not using any menu. It is using a form where you are asked to input the data. You have to type the data that you want to get or you want to extract from the database. Okay, Shabab?